So now we'll start for the second part of 2.47, and that part says, what is the maximum speed you could have and still not hit the deer? So what's changed? Well, what's changed is they're asking for the initial velocity so that you go a total displacement of 35 meters. So now we don't know what the initial velocity is. We also don't know what the position is at point 1. And the deer is our final point. Okay, so how to proceed? Well, let's look at what's going on between the initial and the first point there. So if I pick an equation to relate those 2 points, I have the equation position 1 is equal to the initial position plus the velocity, the initial velocity times the time between those 2 points. We've labeled from before our initial position to be the origin, so let that go to 0, and now I have this relationship x1 is equal to the initial velocity times the time between points 0 and 1. Okay, so I do know that the time between point 0 and 1 is half a second, so I can put that in. Now, let's relate these 2 points to each other. I don't know the time between those 2 points, so I'm going to pick an equation that relates them without using the time. So v2 squared is equal to v1 squared plus 2a1 times delta x between 1 and 2. That relates the 2 points, 1 and 2. I know that v2, the final velocity, is going to be 0. We want to stop at 35 meters. Also, I'm going to write this out because I have an expression for x1. Is x1 somewhere in this equation? It is v1 squared plus 2a1 times what? x2 minus x1. So let's plug in because we have an expression for x1. So we have v1 squared plus 2a1 times x2 minus v initial times 0.5 seconds. So if we simplify, on the left-hand side of the equation, we have 0. On the right-hand side of the equation, we have v1 squared plus 2a1 times x2, and then simplify minus 2a1 times 0.5 times v0. But we also know that the velocity of v1 and v0 is the same. So let's plug in. That's equal to v0 squared plus 2. We know a1 is negative 10 meters per second squared. We know that x2 is 35 meters. Fill in some more details. a1 is negative 10 meters per second squared times 0.5 seconds times v0. It's looking a little bit messy, but let's simplify it a little bit further. We get 0 is equal to v0 squared, and I'm going to move this term over to be the second term, plus, if you simplify all of this, you're going to get 10 meters per second times v0, and then move this constant term over, and you get minus 700, and you get meters squared over seconds squared if you're paying attention to the units. So actually, this is a quadratic equation. that the coefficient on the squared term is 1, coefficient on the second term is 10, and then the constant is negative 700. So if I put this in my solver, I get V naught equals 22 meters per second. So if I put this equation into my TI-84 solver and ask it to solve the quadratic equation, of course you could also use the quadratic formula, you're going to get a positive root of 22 meters per second. The negative root doesn't mean anything. To ask is this a reasonable answer? And it does seem reasonable that initially we had a velocity in the first part of the problem of 20 meters per second. So now the car is moving at 22 meters per second to start, and it goes a total distance, an increased distance of 35 meters instead of 30 meters. So it seems like our answer makes good sense and checks out.